In the last class, we were discussing about the flowcharts, how the structured approach to programming can be taken over or handled by this flowchart. It was being discussed. Now, in this class, what we will discuss is algorithms, pseudocode, as well as flowcharts of some of the most popular algorithms or most popular codes that is to be used in your programs. So we will see what is an algorithm. We have already seen what is an algorithm and what is the difference between an algorithm and pseudocode, etc. What that we will see, and the difference between algorithm, pseudocode, and flowchart. That already we have seen all those things, and now we will discuss about some of the most popular or the simple algorithms actually. So as an informal definition for an algorithm, it is a step-by-step method for solving a problem or for doing a task. That is, we have some input parameters or input list is there. Then some algorithm, some process is to be done in the input list. That is, the input list may be some data that is to be processed. Then the algorithm is how this particular data is to be processed. That is a step-by-step method for solving a specific problem using the given data. Then the output list. The output list may be the output result of this particular problem. So that is an algorithm. That is a step-by-step method for solving a specific problem or doing some specific task. Then let us see the algorithm for finding the largest integer among 5 integers. So what we are given is 5 integers are given, say in the topmost box there are 5 integers, 12, 8, 13 and 11. So we have to find out the largest among them. Obviously by looking into those numbers we can find out, we humans can find out the largest number is 13. But as a computer it cannot find out whether 13 is the largest or 8 is the largest. In order to find out whether which one is the largest, it has to check each and every element. So that particular checking is done through the algorithm. So an algorithm for checking it is given here. That is, we first set the first value as the largest one. That is, the 12 was the largest one. We take a variable, some variable or some space where we can store values. So we take it as the largest, and the largest is set as 12 in the initial step. And in the next step, what we do is we compare this 12, this largest value, with the next value, that is the second value, that is 8. So obviously 12 is the larger one, so we keep the 12 as the largest one itself. Then we keep in the next step, what we do is we check this one with the third element. So the third element is 13. So obviously 13 is larger than 12. So we change that largest value to 13. So now the largest value is 13. So in the next step, again we check for the next number, that is the 9, whether 9 is larger than 13 or not. So obviously it is not, so we keep the largest as 13 itself. Then in the last step, what we check is whether 11 is larger than the largest or not. The largest is 13 and 11 is obviously smaller than the largest. So we keep largest as 13. Now we output the result, that is the 13. This is possible only, or these steps, all these steps can be enumerated only when there is a finite number of elements available. That is, only 5 elements or 10 elements are available. We can write step by step. So that step-by-step writing is known as the algorithm. So this is the algorithm for the previous process that we have described. Set the largest to the first number. Then we check if the second number is greater than the largest, set the largest to the second number. Then third step, if the third number is greater than the largest, set the largest to the third number. Next step, if the fourth number is larger than largest, set largest to the fourth number. Then the last step, if the fifth number is larger than the largest, set largest to the fifth number. Then we output the result. This is an algorithm. This is the most simplest form of the algorithm that we have described in the previous slide. But the problem with this one is if the number of elements is too large, that is, say if there are 100 or 1000 numbers, then you have to repeat this same step for 100 or 1000 times. That is not possible. That is not a practical approach to writing an algorithm. So then how we can refine this particular algorithm? Let's see. So in order to refine this, the first refinement is done in the case of setting the largest value. That is, the largest value can be set to 0 because all the values in the input list is positive integers. If all the values in the in the input list is positive integers, then we can set the largest value to 0. Then we check, we can repeat the steps that we have described before. That is, we can do the same steps. If the current number is greater than the largest, set largest to the first current number. So this step can be repeated n times. That is, n times means if there are only 5 numbers, so 5 times we can repeat. So then we output the result. This is again a crude form of the algorithm. We can refine it to a shorter algorithm. So this is the generalized form of the find the largest algorithm. That is, we have n number of integers available. We doesn't know what is the value of n. It can be 100, it can be 1000 or 10,000, whatever be it. This particular algorithm is valid. In the previous case, it was valid only for the 5 numbers. If there is a sixth number, it was not valid. But in this case, depending on the size of the n, it can be changed. That is, it can be 6, it can be 5, it can be 100, it can be 1000 or 10,000 or 1 lakh, whatever it is. So here the algorithm is like this. In the first step, we set the largest to 0. Then in the next step, what we do is repeat the following step n times. N is the number of items within this particular element, particular array. Then if the step that is to be repeated is if the current number is greater than the largest, then set the largest to the current number. Then finally we print the largest value. So only this much is enough for find largest algorithm. So from the initial crude algorithm, we have come down to a very small algorithm, very small in the sense all the steps are involved, but the number of lines that is to be written in this particular algorithm is only 3 or 4. So now in any algorithm, there will be 3 constructs. When we write the algorithms or pseudo-codes, there will be 3 constructs. As in the case of structured approach to programming, we have discussed about these 3 constructs, and in the flowchart, when we discussed about the flowchart, we discussed these 3 constructs. These 3 constructs are: one is the sequence, that is a continuous set of operations, one after the other. That is first action, then second action, then third action, etc. to action end. There is no branching or no condition checking is happening. So that is the first construct. That is a sequence that we have already discussed. Then another one is a decision construct. A decision construct is we are checking for a specific condition, whether a condition is true or false. If the condition is true, then some series of actions are done. This is done if the condition is true. If a condition is true, then do a series of actions. This series of actions can be either another sequence, another decision, or another repetition. So any of these 3 constructs can replace this do a series of actions. So else, that is, if the condition is false, if the condition that we checked in the decision construct is false, then we have to do another series of actions. Again, in this case also, in this another series of actions also, it can be any of these 3 constructs. Then the third construct in an algorithm is the repetition construct. That is, while a particular condition is true, do action 1, do action 2, etc. up to do action n. This particular condition also, this particular box, that is the actions, the series of actions, need not be always a sequence. It can be a decision or another repetition or another sequence also, that is possible. So these are the three constructs. Then the pseudocode for the three constructs is the sequence. The pseudocode will be almost the same. That is the action 1, action 2, action n, etc. In the case of decision, it is normally written as if the condition. Instead of writing it in verbal terms, if a condition is true, what we are doing is we are incorporating some of the codes of that particular programming language. Since we are studying C programming, we are incorporating the programming codes of this C programming. That is why this if is coming up. If is for C programming. So if that particular, then within bracket the condition, whatever the condition is to be checked, then that condition. If condition, then if that condition is true, then what is to be done? The action. Else, if the condition is false, the type of actions that is to be done. Then finally an end if. So this is the decision structure. Decision construct in the case of a pseudocode. In the case of a repetition, again, while. This while is another construct or another keyword in the case of C programming. So while this condition is happening, then the different actions that is happening. Then we end the while. So from these two slides, we get an idea about the difference between an algorithm and a pseudocode. An algorithm is actually a verbal representation of the process that is to be followed or the actions that is to be followed in order to do a specific task. The pseudocode is having some sort of the programming language incorporated into it. That is, instead of something like adding two values, in the algorithm we will be having add the first value to the second value. But in the case of pseudocode, you can write it as A plus B. So that sort of some sort of the programming codes is incorporated into the pseudocode, into the algorithm. Then it becomes a pseudocode. Both are the same thing. That is, algorithm as well as pseudocode are the same thing. Same thing in the sense both represents the same step-by-step procedure that is to be followed, or the step-by-step actions that is to be done in order to do in order to solve a specific problem, or in order to do a specific task. Then we can see some of the algorithms for some simple processes or some simple things that is to be done. So the first one is write an algorithm that finds the average of two numbers. So we have to find out the average of two numbers. The algorithm for this average the average of two numbers is, the input is the two numbers. That is, we start with the input, that is the two numbers are input into the program. Then we add the two numbers. Then divide the results by 2. Return the result in step 2. That is to be done. That is, we have to first input the two numbers, then we add the two numbers, then we divide the result, that is the addition of the two numbers, by 2. Then we return the result that is obtained in the step 2. So if we write the pseudocode for this, the first step will be input two numbers, say A and B. Input two numbers A and B. Now this add the two numbers. This can be replaced. This can be replaced with A plus B. Say equal to C. Sorry, C equal to A plus B. C equal to A plus B. So this can be written. They add two numbers. Then divide the result by 2. So the result R equal to the final result, or the average. Say V average, AVE average equal to C by 2. So this can be given. These steps can be given in the case of pseudocode. But in the case of this is to be replaced. This one is to be replaced with the average equal to C by 2. Then return the result, not the result, return AVE. So that is it. So this is the difference between an algorithm and a pseudocode. In the case of algorithm, we are representing it verbally, and in the case of pseudocode, what we are doing, we are incorporating some sort of the programming language into the algorithm. Now, in the next example, write an algorithm to change a numeric grade to a pass or no pass grade. That is a specific value, specific mark is given, a numeric value is given. It has to be checked whether that particular mark, a student with that particular grade or particular mark is having a pass grade or no pass grade. So for that one, what we have to input is one number, that is the mark of that particular student. And we check if the number is greater than or equal to 70. So if the benchmark, I mean the threshold mark is 70, that is if the person scores 70 or more, then he gets a pass mark. So that is the condition. So if the number is greater than or equal to 70, then select the grade to pass. Else set the grade to no pass. That is, if the grade is less than 70. If the grade is less than 70, then set the grade to no pass. That is, he is failed. And then we end this if. Then we return the grade. So then finally the end. So this is an algorithm for a pass or no pass grading. Now the example 3. Write an algorithm to change a numeric grade to a letter grade. That is, there are multiple categories of grades are available. In the previous case, only 2 types of grades are available, whether it is a pass or no pass. In this case, A, B, C, D, E, etc. different grades are available. So in that case, what we will do? We input one number, that is the number corresponding to the specific mark. And if the number is between 90 and 100, both inclusive, that is 90 as well as 100, from 90 to 100. If the mark is between 90 and 100, that is both inclusive, means it is inclusive of 90 also. If the person gets 90 mark also. So in that case, set the grade to A. Then in the next step, we check if the number is between 80 and 89. Then if it is between 80 and 89, both inclusive, then we set the grade to B. Again, in the step 3, we check whether the number is between 70 and 79. Then if it is between 70 and 79, we set the grade to C. Then in the 4th step, we again check whether the number is between 60 and 69. We can set the grade to D. And finally, that is in the 5th step, we check whether the number is less than 60. If the number is less than 60, then we set the grade to F for failed. So the last step what we do is we return the grade whatever is the grade. It can be A, B, C, D, or C, D, E, or F, whatever be the grade that is being returned. This is actually a very crude form of the letter grading algorithm, because we are checking it 5 different times, whether it is between 90 and 100, between 80 and 89, 70 and 79, etc. We are checking it different times. But instead, once we obtain a specific grade, then we can break from there to the end, that is go to the 6th. So that is also possible. That sort of writing the algorithm in a similar way is also possible. Now, the next algorithm is write an algorithm to find the largest of a set of numbers. You do not know the number of numbers. That we have already seen in the case of 5 numbers. If we set the n to 5 to n, what we does, that we have seen. So this is that was the simplest form of the algorithm. But if you want to include a better algorithm, include the better algorithm in a sense that which is much closer to the pseudocode. Some algorithms are much closer to the pseudocode. In the previous case, when we read it, when we have written it as repeat it n times and find check with the current number, that check the current number is greater than largest or not. So that sort of writing, that is the crude form of the algorithm. But in a good algorithm, it includes some part of the pseudocode also. That is, there is not much a large differentiation between an algorithm and a pseudocode when we write it properly. So in this case, the input is a list of positive integers. We doesn't know what is the number of integers. So we set the largest to 0. Since it is only positive integers, if there are negative integers also, then we have to rethink about this particular value, that is largest to what value should it be. Then we check while more integers, that is more integers are present in that particular algorithm, I mean in the particular list. In that particular list, if more elements are there, then if that particular integer is greater than the largest, then set the largest value to the integer end if, end while. So end if, this end if is for this if, and this end while is for this while. Then finally we return the largest. So this is the algorithm for finding the largest among n numbers, or for a number of elements in a positive number of positive integers in a list, for which we doesn't know how many integers are present there. So another version of the same algorithm with the largest, there are only 1000 numbers present in that case. That is, write an algorithm to find the largest of 1000 numbers. So in that case, we input the 1000 positive integers. In the previous case, it was a list of positive integers. We doesn't know how many integers were there. So here there are only 1000 positive integers. We know that there are 1000 positive integers. Then we set the largest to 0. Then set a counter to 0. This counter is used in order to check for this 1000 numbers. More than 1000, we don't have to check. So while counter is less than 1000, that is, in the previous case we were checking whether there is other values possible or not, other values are present in the list or not. But here what we are checking whether this counter is less than 1000. If the counter is less than 1000, then we are checking if the integer is greater than the largest. If the integer is greater than the largest, then we set the largest to the value of the integer. If it is less, then we does nothing. Then once this checking is over, we increment the counter. Increment the counter means counter is equal to counter plus 1. Plus 1 is also added, so that the next number is to be checked. The second number or the third number is to be checked. So then we end the while. So then finally we return the largest. And that is how we write the algorithm for finding a largest of 1000 numbers. Now there is a concept of sub-algorithm. Sub-algorithm is a separate algorithm which is not included in the main algorithm, but it is given a separate name, like this one. So find the largest. We have seen the find largest. So input is a list of numbers, set the largest to 0, then while more integers, that we were doing. So instead of writing everything that were here, what we do is we write it as find larger. That is, we have to check whether the current number is larger than the first one, the current largest or not. That is to be checked. So we separate it as a separate function, that is, or a separate module. So then this particular module is written as a separate algorithm. It is find larger algorithm. So this is this find larger algorithm. So in the find larger algorithm, the input is the largest value as well as the current integer. So if the integer is greater than the largest, then set largest to the value to the largest to the value of the integer. So that's it. So this is the concept of a sub-algorithm. Then the sub-algorithm can be written as a separate block in another space. If this is useful when, as in the case of sub-flowcharts, we have seen modular flowcharts. So in the modular flowcharts, and because of the space limitations, you could separate a specific part of that particular flowchart to another part, another space. So likewise, you can, in the case of a sub-algorithm also, you can separate the sub-algorithm to another part. Now we will see two most important algorithms that is given in your syllabus, that is to be studied and given in your algorithm. One is bubble sort and the other one is linear search. So in bubble sort, as you can see, this animation, in this animation, the bubble sort is animated here. So we have to arrange a number of elements in an ascending order. That is, the largest one should be towards the right and the smallest one should be towards the left. So in the bubble sort, what it does is, in the first iteration, it takes the largest value or the largest element among all the elements and it puts it on the rightmost position. So see, in this animation, the red bar, that is the largest one, that is the current largest one. So it is moving the largest one towards the rightmost position. Then obviously the smaller ones will be shifted towards the left. And finally, what we end up, what we will have is a list of items that is sorted in the ascending order. Okay, we will describe it a bit deeply. That is the example of a bubble sort. We are having a 5-element array or a 5-element list we are having. So in the iteration 1, what we do is we check the in the first step. What we do is in the first step we check the first element with the second element, whether the first element is larger than the second element or not. In this case, the second element is the larger one. So we does nothing here. And in the second step, that is here, this is the first step. I equal to 0 is the first step, I equal to 1 is the second step, etc. So in the second step, what we do is here, what we do is we check the second element with the third element, whether the second element is larger than the third element or not. The second element is larger than the next element or not. So here 45 and 0. So 45 is larger than 0. So we have to swap it. We are swapping it. 0 becomes at the place of 45 and 45 becomes in the place of 0. So in the next step, see, the 0 and 45 are swapped here. So in the next step, that is in the step 3, we are checking the third element with the next element, that is the fourth element. Again, 45 and 11. So 45 is the larger one. So we have to shift it or we have to swap it. That is 45 is shifted to 11 and 11 is shifted back to 45. So see in the next step, that is in the iteration 4, this 11 and 45 are shifted or swapped together, swapped between each other. Now what? The last two elements are to be checked, that is 45 and minus 9. So 45 is the larger one. So we put 45 towards the end, that is towards the rightmost position. So in the last step, after the first iteration, the elements in that particular array will be like this, that is minus 2, 0, 11, minus 9, and 45. So initially it was here, it was minus 2, 45, 0, 11, and minus 9. So here it was the 45 was shifted towards the rightmost. That is actually what we are doing is we are bubbling up the largest value among the list, and we are shifting it towards the rightmost position. That is why it is known as the bubble sort. Now in the second iteration, what we do is the largest one is towards the right. So we don't have to check it again. So in the first step, we check for the first two elements, that is minus 2 and 0. So 0 is the larger one among minus 2 and 0, so no action is being done. Then again, in the second step, that is this is the second step, 0 is checked with 11, so no change is to be done because 11 is larger one. In the third step, again it is checking whether 11 and minus 9, which is the larger one. So obviously 11 is the larger one. So we are swapping it with each other. That is 11 occupies the space of minus 9 and minus 9 occupies the space of 11. So this is happening, minus 2, 0, minus 9, then 11 and 45. So these two, the last two positions are in the order. That is the second largest one is at the second last position and the largest one is at the last position. So in the iteration 3, again, we check minus 2 and 0, which one is the larger one. So 0 is the larger one, so 0 stays there. Then we in the next step we check 0 and -9. So -0 is the larger one, so we swap it. So this procedure repeats. Then in the iteration 4 we have to check only -2 and -9. So -9 is lower than -2 or smaller than -2. So it is being swapped. That is -9 comes at the first position and -2. Now this list is in the sorted form. That is sorted in the form of in the ascending order. That is -9, -2, 0, 11, and 45. So this is how the bubble sort works. Now let's see what is the algorithm for this one. So this is the algorithm for bubble sort. That is, we start in all the algorithms. We have to the step 1 should be the start and the last step should be a stop. So we start, then we read the array of the given items from the user. Then what we do is we set the iterations to be 1 and j equal to 0. J is for the different steps and iterations is for different iterations, as we said in the previous case, in the previous slides. So check if iterations is less than n. If it is false, that is if iterations is greater than or equal to n. If it is false, we go to step 8, that is print the sorted array. That is, if no more iterations is possible, that is n number of iterations are already done, then we can print the sorted array. Else, if the iterations is less than n, in that case, what we do is we check if j is less than n by n minus 2. So that is j. The last number is the last number and the previous number is to be checked. So that is why n minus 2, because we start with j equal to 0. So j equal to n minus 1. That is the maximum number of elements. The index of the maximum number of elements that is possible is n minus 1. That is the case with the C programming. That is, the index of an array starts with the 0 to n minus 1. If there are n elements, suppose if there are 10 elements, then the index will be 0 to 9 only. There won't be a 10th. The 10th element will be will be having an index 9. So that is why we are doing this j less than n minus 2. If again this is false, that is if j is greater than or equal to -2, then we increase the iterations and j equal to 0 is also done. J is reset to 0. And we go to step 4. That is from here, from this step 4 means this is we are going back to here. So we are again checking the iterations is less than or not. If j is less than n minus 2, in that case, if j is less than n minus 2, we check the array j, that is the jth element of the array is greater than j plus 1 the element of the array. That is, if j is 0, array 0 as well as array 1, that is the 0th element as well as the first element, or element with the index 0 and index 1. That will be the first element and the second element, whether the first element is greater than the second element. So that sort of checking is being done. Again, if this is false, then we increase j plus plus. That is, if array j is not greater than array j plus 1. So then we have to do nothing. So we increase j. The value of j is increased. And again, we go back to step 5. So here, the step 5. So we have to go back to this step 5. So else, that is if array j is greater than array j plus 1. If array j is greater than array j plus 1, then array j and array j plus 1 are swapped. That is, both are swapped with each other. And then we increment the value of j and go to step 5. Again, we go back to step 5. And finally, at time comes when this condition, that is iterations becomes greater than or equal to n. At that time we print the sorted array. Then we stop it. That is the algorithm for the bubble sort. Now we can see the flowchart for the bubble sort. The flowchart, we start. So this is equal to this one. The flowchart as well as the algorithm is together. This is equal to this one. End is equal to this, equal to stop. Iterations is equal to 1. So we set the iterations to 1, and here j equal to 0. So j is equal to 0 is set. Then we check the iterations is less than n. We check the iterations is less than n. If it is false, that is if iterations is not less than n, then print the sorted array. That is the step 8 is this one, the sorted array and end. So here. Then if iterations is less than n, then we go for this one. That is if this condition, that is step 5. If j is less than n minus 2. So j is less than n by minus 2. That is we are checking this one. That is if j is less than n minus 2. If j is not less than n by n minus 2, then in that case, if it is false, the iterations is increased by 1. This plus sign indicates that iteration is increased by 1. That is iterations, the value 1 is added to this particular variable, that is a variable known as iterations. So it is added to 1 and then it is again coming back to this step, that is j, we are setting j equal to 0. And then iterations is, we are checking whether iterations is less than n or not. Then else, if j is greater than or equal to n minus 2. So in that case, we check whether array of j, j of array is greater than j plus 1 of array. So if this one is not true, that is if array of j is not greater than or equal to array j plus 1, so we go back to j plus 1, j plus plus, that is j is increased. The next position is to be checked, so it is being increased. So then it comes back to we are checking whether j is less than n minus 2. So this loop repeats. Then if this one is true, that is array of j of array is greater than j plus 1 of array. So in that case, we swap array j as well as array j plus 1. So these two values are swapped. Then again, we go back to j plus plus. So this is the flowchart for the bubble sort algorithm, and here is the algorithm for the bubble sort. So these two can be mapped together. That is these two. Once you got the bubble sort algorithm, or once you got the algorithm, you can map it to this flowchart, and the flow. If you have the flowchart, then you can create the algorithm. Actually, both are the same thing. That is, both represent the same processes, the same steps, or the same actions that is to be taken in order to achieve some specific task, or in order to solve some specific problem. The only difference between these two things is that one is a verbal representation of the process, and the other one is a graphical representation of the process. The flowchart is a graphical representation of the process, which gives you a better idea of what is happening, because it is visually understandable. It can be understandable by visually, without reading much, without thinking much. We can understand it. That is like here, if iterations is less than n, if yes, that is if true, then we have to check j is less than n by minus 2. Again, here it is yes or no. So this sort of representation is is also needed. That is, a flowchart is also needed while writing an algorithm. The advantage of a flowchart is it is better understandable than an algorithm. So an algorithm, as well as the difference between an algorithm, a flowchart, and pseudocode is that both represent, all the three represent the same thing. That is, all the three gives you the step-by-step approach to all the step-by-step actions that is to be carried out in order to complete a specific task, or in order to solve a specific problem. The difference is that the algorithm is verbal representation. The pseudocode is also a verbal representation, but it has some sort of the programming language incorporated into included into the steps. And the third one, that is the flowchart, is actually a graphical representation of both these things. That is algorithm as well as the other one, the pseudocode.